Hello, welcome to Anybody Can Learn. Today we will solve some problems related to kernel regression. So common data for question 6 and 7 is kernel regression with a polynomial kernel of degree 2 is applied on a data set x, y. Let the weight vector be, this is our weight vector wx, and this is called as a alpha. The matrix is called as a alpha. Question 6. Which data point plays the most important role in predicting the outcome for an unseen data point? Write the data point index as per the matrix X, assuming the index start from 1. How is the weight vector different in linear regression and kernel regression? In linear regression, we learn the weight vector directly, but in kernel regression, weight vector is a combination of training data. Formula in linear regression is y is equal to w transpose x, and weight vector is written as w is equal to column vector w1 w2 up to wn transpose. Whereas in kernel regression, formula for w is x multiplied by alpha, and it is written as w is equal to x column vector alpha 1 alpha 2 up to alpha n. The weight vector is the final vector used for making prediction. Training data matrix capital X is the, suppose we have the 5 training samples. X is a row vector with x1, x2, x3, x4, x5 entries. That is, each column is exactly the one training sample. That is, this x1 is a one training sample, x2 is another training sample, x5 is another training sample. Now alpha tells us how important each training sample is. Suppose we have alpha given as a row vector with entries 0.3, 1.6, 4.2, minus 0.5 and 0.9. Let's arrange these in our simple table. That means data point 1 correspond to alpha 0.3, data point 2 correspond to alpha 1.6, data point 3 correspond to alpha 4.2, data point 4 correspond to alpha minus 0.5, and data point 5 correspond to alpha 0.9. Notice that the third data point 4.2 is the largest coefficient. Therefore, our third data point 3 contribute most to the prediction. Remember that the data point which has the largest coefficient contribute most to the prediction. Now consider our question number 6. In a kernel regression, importance is determined by the alpha coefficient. The larger the coefficient, the greater its contribution. So in question 6 we have given the alpha as 1.2, 2.5, minus 0.8, 3.6 and 1.5. That means data point 1 correspond to the alpha 1.2, data point 2 correspond to the alpha 2.5, data point 3 corresponds to the alpha minus 0.8, data point 4 corresponds to alpha 3.6, data point 5 corresponds to alpha 1.5. So which one is the largest? Clearly 3.6 is the largest. The data point belongs to 3.6 is a fourth data point. So its index is 4 because index start from 1. Therefore, our final answer is 4. Consider a question 7. What will be the prediction for the data point row vector 0, 0, 0, 0, 0 transpose? For polynomial kernel, the formula of k of xi, xj is equal to xi transpose xj plus 1 square. K of xi, xj measures the similarity between the two data points, and xi transpose to xj is a dot product, inner product. It measures how similar the two vectors are. One means the bias term and 2 is polynomial 2 degree polynomial. So kernel measures the similarity between the two data points. How do we make a prediction then? A kernel regression predict the final value using this expression y hat is equal to summation where I ranges from 1 to n alpha I times k of x test comma xi, that is y hat is equal to alpha 1 into k of x test comma x1 plus alpha 2 into k of x test comma x2. This goes on until alpha n multiplied by k of x test comma xn. So the flow of calculation is, first find the kernel with each training sample, then multiply that kernel with the alpha, then sum all of them and they will give us the prediction, that is y hat. So first find out the kernel, that is k of xi comma xj, which is calculated by the formula xi transpose xj plus 1 whole square. The question has given the x test as a row vector with entries all zeros entries. So calculate the dot product with xj. So x test transpose xj is 0. Why this happens? Because we have given the x test as row vector with all zeros entries. If we multiplied with any vector, it will give 0. Suppose our xj is row vector with entries 2, 3, 4, 5, 6. Then if we multiplied this xj with this x test, that is this 0 matrix, then 0 multiplied by 2 plus 0 multiplied by 3 plus 0 multiplied by 4 plus 0 multiplied by 5 plus 0 multiplied by 6, these all will give us 0. This happens for every single training sample in this example. So substitute this in our k of xi xj formula, that is the formula is xi transpose into xj plus 1 whole square. Just now we calculated that xi transpose xj is 0. So substitute it into formula. Therefore k of xi xj is equal to 0 plus 1 square, that is 1 square. 1 square means 1. Therefore k of x test comma xj is 1. This is true for every single training sample in this problem. Now write the formula for the prediction, that is y hat. y hat is calculated by the formula summation of alpha I, where I range from 1 to n, multiplied by k of x test comma xi. Just now we calculated the k of x test of xi as 1. So 1.2 multiplied by 1 plus 2.5 multiplied by 1 plus minus 0.8 multiplied by 1 plus 3.6 multiplied by 1 plus 1.5 multiplied by 1. This 1.2, 2.5, minus 0.8, 3.6 and 1.5 are the alpha given to us. So 1.2 plus 2.5 is 3.7, 3.7 plus minus 0.8 is 2.9 and 2.9 plus 3.6 is 6.5 and 6.5 plus 1.5 is 8.0. So our y hat, that is prediction, is 8. Some important formulas are: weight factor is x is equal to w is equal to x multiplied by alpha. For polynomial kernel of degree 2, k of xi xj is equal to xi transpose xj plus 1 whole square, and the prediction formula is y hat is equal to summation from 1 to n alpha I multiplied by k of x test xi. Thank you.